welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Alameda International High School. And in this video, we're just going to be doing some mixed review ideas for this in preparation for our next assessment. So that fifth concept that we were talking about is going to be the exponential function. So is it going to be growth? Is it going to be decay? Well, we're going to say that, hey, since our base is going to be positive and it's going to be between or greater than, it's greater than 1, we know that this is going to be growth. So that means that our values are going to be increasing. So that means this, what I can do is I can type in my function. So what I'm going to do is I'm going to go to that y equals, I'm going to go ahead and choose that y1 as my function. So I can say this is y1. So I type it in, I have parentheses, 3. Make sure you hit that exponent button. I'm going to say exponent, and I have x plus 1. Be sure to hit enter to store it. And so now I have my first function. And then to get to that table of values, again, make sure you can make that list. So I hit second graph to get my list of values. Again, I want to start those values at -3. So it's going to look like something like this. I'm going to have and say that when x is -3, my output or my y value is going to be at 0.1 repeating. Again, that little line above the 1 just means that the 1 keeps going like that. If you wanted to write out all those decimals, you certainly could. And then for -2, it has 0.3 repeating. For -1, it has 1. For -2, for x equals 0, I have a positive 3. For x equals 1, I have a positive 9. For x equals 2, I have 27. And for x equals 3, I have 81. So when you go to plot those points on the graph, again, make sure that your best approximations, try to make sure you're showing that it is growth, and so those values are going to be increasing. If you want to see what that should look like, again, you can hit just graph, and it will show, notice how those values are increasing, and then right as it passes over 0, notice how it rapidly increases. What we mainly want is we want to plot these ordered pairs. So again, make sure you know ordered pair is an x and a y. So for every x value, I need a y value. So at x equals -3, I have just a value right above that point. It's not quite in the middle, it's still less than that. When I go to x equals -2, I'm going to go just a little bit higher on the y-axis. When x equals -1, I have y equals positive 1, so I can go right on those ordered pairs, and this is kind of where our graph starts to rapidly change. So when x equals 3, when x equals 0, this is going to be our y-intercept. So when x equals 0, our output is 3. When x equals 1, our output is 9. And notice now that it goes off the graph, we have x equals 2, that's going to be 27, so it's going to be all the way past that point, but that's okay. As long as we get mainly these first, let's say 1, 2, 3, 4. Well, as long as we get those first 5 points, we are good. So notice how it's increasing from left to right. Again, to get this table of values, it's the second, and then graph to get that table of values. All right. So again, I can quit out by hitting second mode, and now I can move on to that number 2. So for this next concept, I'm going to say it's going to be number 2 is going to be the first 5 terms of a geometric sequence are given as 1/9, 1/3, 1, 3, and 9. So again, since it's a geometric sequence, make sure you have that first formula. So I'm going to say something like this. I can have my first for geometric formula, so that formula, I'm going to say I have, actually no, I want to first, let's back up. Let's say let's identify first. So what is our first term? Our first term is 1/9, and our common ratio is going to be what? Well, it's increasing by how much? Well, we're multiplying by 3 each time. Again, you notice how I multiplied 1/9 by 3, you get 1/3. 1/3 times 3 is 1. So again, make sure you're saying that common ratio is going to be 3. Now we can go, so we identified we have our formula. So we say our formula is going to be u sub n, the nth term, is going to be u sub 1, the first term, times that common ratio r to the n minus 1 power. Again, we can substitute in our values for our variables, and so I'm saying u sub n is going to be equal to, we have 1 over 9, and our common ratio is 3 to the n minus 1 power. And this is helpful because what you can do is use this in your table of values. So what I can do is I can write as a function. So I write this as a function. I can say y is going to be equal to 1 over 9 times 3 to the power x minus 1. The reason why I'm doing this is because when I hit y equals, I can have that point, or I can have this in my function. So I go ahead, I hit 1 over, or I hit parentheses to write a fraction. I have alpha y equals 1, and I say 1 over 9, parentheses, and I can say 3 power x minus 1. Hit enter, so that way it's stored in there. The reason why I'm doing this is because I can plug in my value for my variable. So again, when it says find the 13th term, that just means let n or x equal 13. So it looks something like this. So I'd say u sub 13 is equal to 1 over 9 times 3 to the power of 13 minus 1. Make sure you work in the exponent first, so that's going to be equal to 1 over 9 times 3 to the power of 13 minus 1, which is 12. If you want to evaluate first, and we can use that table to check, so I have 13, I have 3 to the power of 12 first, gives you that large number, so I can say this is equal to 1 over 9 times 531,441. So I can take that answer and multiply it by 1 over 9 to get my value. So I'm going to say the 13th term should be 59,000, there we go, 59,049. So let's find out. Again, I substitute in my values for my variables and simplified, but what I can do is I have my sequence in this function, and so I can hit my second graph to get my table of values. I want the 13th term, so I can scroll down to 13, and boom, there it is. I have the 13th term is what we already have. Alright, so let me clear that out. Moving on to that next one. It reads like this. I can say for number 3, those are sequence word problems. And I can say, alright, since I have a percentage, make sure that you're using that right formula. So let me read it first. So it says the number of students at a school was 420. The population growth, or the population grows 6.9% each year. Nice. How many students will be attending in 7 years? All right, so be careful in this one because we're going to say that when we go to identify our first term, so we say u sub 1 is equal to 420. However, we're going to say r is going to be 1 plus. So make sure you're saying, since that is a percent, we have 1 plus, and we're going to say that decimal amount. So I have 6.9 divided by 100. So make sure you have 1 plus that amount since it is growth. If that was decay, you would have to say that it is 0.069, but it would be subtracted. So I'm going to add those two together to get my common ratio. And so I'm going to say that r is going to be those two added together. You can have your formula, so I have u sub n is equal to our first term, which is 420. Try that again, 420. And I have our common ratio is going to be 1.069. And I'm going to say to the n minus 1 power. So it's asking how many students will be attending in 7 years. So that means that I let n equal 7. Plug in that value for a variable. So we're going to say u sub 7 is equal to 420 times 1.069 to the power of 7 minus 1. Working that exponent first. So we have this is equal to 420 times 1.069 to the 6th power. So what I'm going to do is I can take that value to the power of 6, hit enter, and then what I want to do is I want to multiply that by 420. So I'm going to say that my population, so students, so in 7 years, there will be about 626 students. Again, since we can't really round up because we're saying that, we don't have a whole person, we just cut it off at 626. On the back, we have some solving right triangles. And so for number 4, we're solving for that missing side. And then for number 5, we are solving for the missing angle. So what I want to do first is this. I want to set my calculator in degrees. So I click on mode and I scroll down to where it says degree and I press enter, so that way it is selected. Again, you can make sure it has it at the top for yourself. And I can hit second quit, so that way it is in the right scenario. Okay, so let's have our first things first. Make sure you have that in degrees, and then at the top of the page you can write that Sohcahtoa, that way you know those trig functions. So I have so, which is sine over, sine is equal to opposite over hypotenuse. I have cosine is adjacent over hypotenuse, and I have tangent is opposite over adjacent. Alright, so let's label what we know. So I want to first label. I'm going to say my angle theta is 52 degrees. I say the side opposite of the right triangle. Oh yeah, the right triangle. The right angle is going to be our hypotenuse, so I say label that as H. The side opposite of the angle theta is going to be O, or opposite. And we have the side next to our right angle is going to be adjacent, so I can label that as A. So now that I have my sides, what trig function or trig ratio am I going to use? Well, I can have this. I have A and I have H, so I'm going to use the cosine. So make sure you have A and H is going to be your cosine. So I have cosine of theta is going to be equal to adjacent over hypotenuse. I can substitute, so I want to substitute my values in for my variables. So I have cosine of 52 degrees is going to be equal to A over H, so I have 13 over X. And this one's the little tricky one. When you have that X in the denominator, that just means you have to multiply both sides by X first, and then get X by itself by dividing both sides by cosine of 52. So here's what I want to do. I'm going to multiply first both sides by X. So I multiply both sides by X first. That would give you X times cosine of 52 is equal to 13. Again, I'm just using my inverse operation to get X by itself. Divide both sides by cosine of 52. Cosine of 52. So make sure you're saying, okay, I have X is going to be equal to this. So I have X is equal to, so I do 13 divided by the cosine of 52. make sure it's in degrees, and so I'm going to say x is going to be 21.1. And again, that works out, since I'm missing a side length, again, our answer is going to be not in degrees because we're talking about a side length, and it works out, since this is the hypotenuse, we should get an answer that is larger than 13, which we did. So I'm going to say x is going to be 21.1. All right, and then for that part B, still using the Sohcahtoa, I can first label my side lengths, or my values that I have. So I'm going to say, all right, side opposite of the right angle is hypotenuse. This is angle theta. Opposite of theta is called opposite O, and adjacent is going to be 12. So I'm going to say, all right, I have my labels, now I need my ratio. So I can point to the two that I have. I have x and I have 12, so I have opposite and adjacent, so that means I'm going to use tangent. So I'm going to say my ratio for this one, tangent, is going to be tangent of theta is equal to opposite over adjacent. So then your values for your variables, so I have the tangent of 37 is going to be equal to x over 12. So you can make sure you can plug in your values. So I said x is opposite, 12 is adjacent. To get x by itself, I have to multiply both sides by 12. So I have 12 times the tangent of 37 degrees is going to be equal to x. And so I can say x is equal to this value. Again, calculate carefully, make sure it's in degrees, so that way you don't get a different answer. So I'm going to say it's about 9.04. Again, that works because since we're not solving it for the hypotenuse, we should get a value that is, if we were given the hypotenuse, it would be less than that value, but that still works out because we are good. Okay, similar setup with number 5, but now we're missing that side angle. So again, have your setups down here as well. Again, Sohcahtoa, so that way you can use those identities for yourself. All right, so it says solve for the missing angle. Again, we use those same setup where we label first, pick your ratio, and then we use those inverse operations to solve. All right, so I have side opposite of my right angle is hypotenuse, so 8 is hypotenuse. We have our angle theta, which is what we're looking for. The side opposite of that is called O, and then we have 6 as our adjacent. So I have my labels. I have my ratio. Well, let's find out what we need. So we have A and we have H, and so that means we're going to use cosine. So I have cosine of theta is going to be equal to adjacent over hypotenuse. Substitute in your values for your variables. So when I substitute in my values, I can say, all right, still don't know what the angle theta is, but we can say I know it is going to be 6 over 8 since I have A over H. Again, use those inverse operations. So that means this, I have to take the inverse of this ratio. So I'm going to say theta is going to be equal to cosine to the negative 1 power. I'm going to say still 6 over 8. So again, to get this trig function, I just hit second and then cosine, and you notice that it comes up exactly as we need. So I have cosine to the negative 1 power, and I have 6 over 8 as my ratio. And so this answer is going to be in degrees, which is why it's such a large amount. So I'm going to say angle theta is going to be about 41 degrees. Again, if you need it to round for you, again, notice how it's on float. That means any number of decimal places it will list off. I want it to go to the whole number, so I can say, all right, let's do mode, pick your decimal setting as 0 for when we're missing those angles, and I can say, all right, give me that answer one more time, and we'll be good. Lastly, same idea with part B. I want to label first. And so I can say, all right, side opposite right angle is the hypotenuse. I have my angle theta. Opposite of that is the side opposite O, and I have the side adjacent. So now we have a couple sides for ourselves. We can actually choose what we want. So that means this. I could choose, any of these options and I still should get the same answer. So let's actually find out. I should be able to say, all right, so I have label, ratio. Let's do sine, so that way it's real quick. I have sine of theta is equal to the opposite over hypotenuse. So I have sine of theta, I have opposite, which is 16, over hypotenuse, which is 34. So what I'm doing is this. I'm claiming that if I take and say my angle theta should be equal to the inverse of sine with the ratio of 16 over 34. So I take second sine, I do 16 over 34. So I'm going to say that my angle theta is going to be 28 degrees. Again, make sure you can ask questions for yourself at any point in time, hit pause, rewind, all that good stuff, and as always, super slam that subscribe button.